So far we have learned fuzzy set. Fuzzy set is the basic building blocks for the development of fuzzy system. Now, in the context of fuzzy sets, we have learned different operations, so that from two or more fuzzy sets, how the other fuzzy sets can be obtained. And then we have also learned about the relations between two fuzzy sets to get another fuzzy elements. Today we are going to learn about fuzzy implication. Now, we know that there is a proposition for a fuzzy set A, and which we denote as x is A. So, there is a relation among the propositions. Now, such a relation can be better described with the help of fuzzy implication. So, today we are going to learn about fuzzy implication and the different operations or the computation technique, so that the fuzzy implication can be calculated. So, today basically we will discuss about fuzzy rules. This is the another name of the fuzzy implication in fact, and some examples, and then interpretation of these, and then some operations by which the fuzzy implication can be computed, and one operations which is extensively used in fuzzy system development. It is called the Jardez-Max-Min rule. We will discuss in details about the Jardez-Max-Min rule, and we will illustrate the Max-Min rule technique with some example. So, now let us come to the fuzzy implication, that is also called fuzzy rule. It is also sometimes called as if then rule, sometimes it is called the fuzzy conditional statement. Now, such a fuzzy implication is basically a relation between one proposition to another proposition. For example, see, this is one example of a fuzzy proposition, a fuzzy implication, and here x is A, as we know, it denotes a proposition regarding an element x in a set A, and another proposition y is B. So, it basically gives a relation among the two. This is the proposition and this is the proposition, and then relation in the form of if then. So, that is why it is called if then implication or if then rule. Now, it is necessary to calculate what it does mean. That means, if x is A, then y is B, what value it does return to us. So, we will see that if x is A, then y is B can be expressed in the form of a relation matrix. That means, the fuzzy implication can be stored in the form of a matrix, and it is important to calculate the different entries in the matrix. We probably can recall, if x is A, then y is B, we represent such a implication or rule in the form of a Cartesian product, but Cartesian product is basically the very basic things in this relation. There are many things that can be considered. So, in order to represent a fuzzy implication, that we will learn it. Now, in this context, so fuzzy implication takes in a general form, as I told you, if x is A, then y is B. Here the first part, this is called antecedent, or it is called the premise, and then this part, the next part is called the consequence or conclusion. So, this is the general form of a fuzzy rule, and we are to calculate the fuzzy rule, basically the different membership values that can be applicable to such a rule. Anyway, that will be discussed in details in due time. Now, I can put some example, so that we can understand how fuzzy implication or fuzzy rule looks like. Here I have given some example. If pressure is high, then temperature is low. So, as you know, so pressure is high is another what is called, this is the premise or antecedent, and this is the consequence. In fact, these are the two propositions. As another example, if mango is yellow, then mango is sweet, else mango. It is basically expressed in if then else. So, if then else is another form of course, but sometimes we can represent everything in the form of only if then, and this is a unification method usually followed in a fuzzy system. So, anyway, but if then else also another structure that can be represented only in terms of if then else, that will be okay, we will discuss it about later on. As in another example, this is another, if road is good, then driving is smooth, traffic is high. So, here basically a relation among three propositions, road is good, driving is smooth, and then traffic is high. So, a relation takes the form as I have discussed here with in terms of few examples. So far the notation of representing a fuzzy implication is concerned, it is usually represented using this form. So, R represents a fuzzy rule, and if it is basically if x is A then y is B, it is represented A implies B. So, that is why it is also called fuzzy implication, and I told you such a fuzzy implication is basically a relation from the fuzzy set A to fuzzy set B, and broadly it can be expressed in the form of a Cartesian product. So, it is okay, in a broad sense it is a Cartesian product actually, but there are some methods by which this relation can be calculated in a more mathematical way, that will be a more formal way rather, and we will discuss. We are going to learn this the method by which the fuzzy relation can be calculated. Now, let us see another example, so that we can understand the fuzzy implication better. In this example, let us consider two fuzzy sets P and T. So, this is the P and T, these are the basically denotes the pressure in some scale and temperature in some scale. We can consider pressure and the temperature are the two universe of discourse, giving the value of pressure that is possible and temperature that is possible. Now, let us consider the two fuzzy sets, they are expressed in terms of linguistic variable called the high temperature and low pressure. So, these are the two fuzzy sets, and the two fuzzy sets, say high temperature we denote it as T high, and the degree of membership values for the different element is shown here. Likewise, so the low pressure it is denoted as P low and is represented in the form of a fuzzy set which is shown here. So, given these are the two fuzzy sets, now let us see how the fuzzy implication can be expressed. Now, so fuzzy implication from the two propositions, say temperature is high then pressure is low. So, here the proposition is temperature is high then pressure is low. So, it is basically this is the one okay, we can say this is the A, temperature is high and the pressure is B, say B. So, it is basically we can express this in terms of like this one, okay, sorry, it is not high, so we have denoted the T high and this is B, here P low. Okay. So, the relation or we can say implication between the two can be expressed using the short form T high to P low. Now, using simple Cartesian product that we have already discussed in the previous lecture, we can obtain the relation matrix that is giving showing this it look like this. So, this is the relation matrix R showing this relation R. Okay. So, using the Cartesian product that we know. Now, one interesting point is that here if temperature is high then pressure is low. Now, say suppose temperature is 40, then what about the pressure? So, it is basically if temperature is 40 then it basically shows the pressure. Now, you can see for temperature 40 the pressure, okay. So, I can say P low here, P low, this is basically can be expressed in terms of fuzzy set 1 0.7, then 2 0.7, then 3 0.6 and 4 0.4. Now, so this is basically P low provided that temperature high as 40. So, this basically is a fuzzy set. So, answer is like this. So, this rule gives an answer about the pressure, that is pressure as low for a given temperature, this one. Okay. So, this is basically one implication or purpose of the fuzzy set that we will use in our fuzzy system development. So, these two examples can can be helpful for us to understand how the fuzzy implication works for us. Now, now what is the important concept here? It is that here in this calculation of this relation R, we have used mean max simply a mean formula, right. If T high P low, so the Cartesian product and taking the mean, we obtain these two, these are the different entries. But in a more what is called the sense, more practical manner, there are many other calculations are involved, so that this relation matrix can be calculated. Now, whatever the methods are there, they can be broadly classified into two broad categories. One is called A coupled with B and A-entails-B. Now, these are the basically different techniques or different principles to obtain the relation matrix. So, these not necessarily give the same result, because different method, different principle or different interpretation give the different results actually, but all those results work in a different context of course, but we can use any one method to calculate our relation matrix. So, it is depends on the fuzzy designer, fuzzy engineer who wants to use in its system, that which method he should consider. Anyway, so let us see what are the different methods are there which belongs to A coupled with B and A-entails-B. Now, let us first start with A coupled with B. Now, so A coupled with B, usually the relation are in this form, and it is basically A cross B instead of only mean operation that we have already discussed. So, it basically takes the general form which is expressed here. So, the relation matrix, it is basically is a mu x star, it is a operator, is an operator among the two membership values mu x and mu b y for all x y that is there in the relation. So, here this star is called, specifically it is called an operator, it is called the T norm operator. Now, let us see what are the operations that this T norm operator can signify. Here we see 4 different operations that can be explained, that can be applied, so far the T norm operators are concerned. So, basically operators is symbol star, it can be applied to compute either this or this or this one. So, different same operators can perform different calculations or different results depending on what type of operation that we are fixing for relation in a relation. Now, the first operation, the T norm operator, it is called the minimum, and if you see T mean A B, this is the form, it is a mean A B. So, if A cross B and if we take the mean of mu A and mu B, that is basically the general Cartesian product we have learned so far. So, T mean, that is the minimum T norm operator, is the usual Cartesian product that we have already learned. Now, there is other, it is called the algebraic product. Algebraic product is expressed, is a product of the two membership values. Now, like algebraic product, it is called the bounded product. Bounded product is defined using this expression. It basically takes the value of is a maximum of 0 or this one. So, it will take the value. Drastic product, it is denoted as TDP. So, star can be considered TDP, and if we follow this one, if B equals to 1, it will take the value B if A equals to 1, and it will take the value 0 if A, B both less than 1. So, what I can say is that for the different entries, we can have the different value if we follow the different operations according to the T norm operator. So, if we follow mean, then it will give another relation matrix. If we follow algebraic product, it will give another relation matrix, bounded product another, and if we follow this kind of operation, then it will give another relation. So, relation matrix will vary if we follow the different operations. So, if a particular operation is followed, it will give a unique value. So, it is the concept, that is the A coupled with B the operation. Now, Now, so based on these T norm operators, right, we can automatically define the fuzzy rule that is R A B. We can define a fuzzy rule R A B. So, this fuzzy rule can be, as we told you, that this fuzzy rule can be expressed in terms of a 2-dimensional membership function. A 2-dimensional membership function is basically mu R x y. This is basically the value, this one, and representation of this 2-dimensional membership function is basically takes in the form of a matrix, and usually this is termed as R x y. So, this matrix is this one, where x is any element in this direction and y is any element in this direction. So, x an element particularly belongs to a particular universe of discourse, and y is an element belongs to a particular discourse. So, it is basically universe of discourse y, and these are the element of discourse x. So, this entry whatever it is there, it can be calculated applying the two fuzzy sets A and B, that is from the two universe of discourse x and y, and following T norm operator. So, this is the basic concept of calculating the fuzzy relation, calculation of fuzzy rules. Now, interpretation of A coupled with B. Now, I will come to the interpretation. So, mean operator, as we have discussed already. So, mean operator T mean, it basically takes this form. Now, such a rule is popularly known as Mamdani rule. Okay, if we follow T mean, and in fact, the Cartesian product that we have discussed in last lectures, we follow this A cross B as a mean, and then this one, it basically we follow the Mamdani rule there. Now, algebraic product operator, just we have discussed about just simply a product, then it basically called the Larson rule. So, the different scientists who has proposed these rules according to name, all those rules are named like Mamdani rule and then Larson rule. There are some other rules also, bounded product operator, it is just simply there is no rule as such specific like Mamdani rule or Larson rule, it is just expressed using this formula, and dusty product operator as we have discussed using this one. Actually, no specific rule or the name assigned to this kind of things are there, they are basically the different way to calculate the fuzzy implication. Now, I will come to the another type, it is called A-entails-B. Now, A-entails-B takes 3 forms in fact, the 3 forms are called material implication, the propositional calculus form, and another is called extended proposition calculus form. Now, according to the material implication, a fuzzy rule is described in the form like this one. So, fuzzy rule is here is basically A complement union B. So, we know how to perform this operation A complement union B. So, this rule can be obtained like this. Now, the proposition calculus takes slightly different form, which is shown here. It is basically A complement union and then A union B. So, it also take this form, and the extended propositional calculus take this form. Now, what we can learn from all these things, all this discussion is that, so the different way of calculating the relation matrix, that is all. Whether these things are equivalent or not, that is another question. What I say that this may be, this is and this is not necessarily the equivalent. This means that if we follow this and if we follow this, they not necessarily give the same relation matrix. The different relation matrix interpretation may be different, and then purpose or the application may be different. So, that is the thing, and regarding application, it is not okay, it is not the right time to discuss. When we will discuss about its application, then we will discuss about this meaning, that what are the different contexts, the different rule that can be, the different way the rule can be calculated is applicable. Now, so A-entails-B needs certain more discussion about how they work for us. Now, I will go one by one to discuss each and everything. So, the first rule, it is called the Jadez arithmetic rule that we have discussed, a material implication in fact. So, this Jadez implication is basically the material implication. It is according to the Jadez name, it is called the Jadez arithmetic rule, and Jadez arithmetic rule, that means if the two values A and B, two membership values A and B given, then the relation entries for these two values can be obtained according to this formula. Is basically 1 and that means it is basically mean of 1 and the mean of the result of this one. Now, another implication, that is basically the propositional calculus. This rule is again proposed by Jades and it is called the Jades max mean rule, and its notation is like this. So, it basically expressed in this form. It is basically max of 1 minus a and then a and b. So, max of 1 minus a and b. So, this way, okay. So, this basically the method or calculation to find an entry for two different values there and this one. So, this is basically the two rules which is in the techniques of called A-entails-B, and there is another rules also belongs to A-entails-B. It is called the Boolean's fuzzy rule. Boolean fuzzy rule takes this form. We can see this is already expressed the material implication according to the Jades mean rule and here arithmetic mean rule, but here in this context Boolean fuzzy rule they have given the different interpretation 1 minus a or b. Similarly, the Gaussian's fuzzy rule is operation is like this, okay, and it is defined by this formula, this expression. So, this is also another way to calculate the relation matrix. Now, here I want to discuss more elaborately about Jades max mean rule. This is the one what is called the method which is frequently used, or more fuzzy engineer prefers this rule to calculate their relation matrix regarding a rule computation. Okay. Now, let us see what exactly the max mean rule. It is basically Jades max mean rule that just now we have discussed it, but it takes slightly different form. I will tell you why this form is. Anyway, so this is basically to calculate the rule if x is a then y is b. So, this also can be say the R from a to b, where a this is a proposition related to a and proposition related to b. So, this is the rule R a b. Now, so far the relation matrix is concerned, and this can be better expressed in the form a cross b union then a complement and y, where y is the universe of discourse for the set B and A is a fuzzy set, B is the another fuzzy set. So, if we use this formula, then we will be able to calculate the relation matrix which basically represents the rule like R A B, where if x is A then y is B. Now, you can recall when we discuss about Jades max mean rule, we wrote that it is basically R A M A bar union A cross B, only this part. But here to make it generalized we follow this one, right. Now, because if A cross B is basically can be stored this result in the form of a two dimensional matrix, and then union A, where A is a one dimensional matrix. So, it is not possible to apply the union operation on this and this one. Now, in order to make it applicable, so another cross Cartesian product is applied over the A cross and y. So, then it gives a relation matrix, two matrices are of same size and therefore, union operation can be applied. However, if we use this one, result can be a bit different, but that is absolutely not an issue, because so far the certain fuzzy is concerned, this result is acceptable. Now, so this is the concept regarding the Jades max mean rule. Now, let us elaborate this max mean rule technique to compute the rule matrix using an example. So, this example I would like to refer here. Say x is a universe of discourse, y is another universe of discourse. This universe of discourse contains 4 elements A, B, C, D, and it contains 4 elements 1, 2, 3, 4. Now, let us consider these are the two fuzzy sets which are defined over x and y respectively. So, A is defined over x and B is defined over y. Now, we want to calculate the relation matrix, that means if x is A then y is B form, and this basically in this form. So, you want to calculate this one. Now, let us see how this value can be calculated. So, the idea is very simple, we have to calculate first A cross B and then A cross Y and then take union. So, the relation matrix A can be calculated. Now, here is an idea about the details calculation, so that we can understand about it. So, you see, so given the two fuzzy sets A and B, you can check that A cross B give this one and A cross Y takes this form. Now, here whenever we consider Y, so Y is basically for all the elements that is belongs to the universe of discourse with their membership value 1. So, Y is basically 1, 2, 3 and 4, and when we compute this result, we take that Y, this is equals to 1 1, because in the fuzzy form 2 1, 3 1 and 4 1. Then we can take the product, Cartesian product, A complement and then Y, taking the mean of this one, and this kind of matrix can be obtained. I hope you have understood these things, that how this can be calculated. Once A cross B and A cross Y is known to us, we will be able to obtain the final matrix, that is basically a relation matrix, and the relation matrix will take this form. So, this basically is a relation matrix, represents a rule. That rule, as I told you, the rule is f, x is A, then y is B. Okay. So, this basically stored, this basically can be represented in the form of a relation matrix. Now, usually we follow in our illustration in subsequent lectures, we follow generally Jardine-Maxmin rule. Otherwise, you can practice or we can compute another matrix, another relation matrix following other operation, like say T norm operator or some other A coupled with B operation, whatever it is. Now, so this basically gives a calculation about a rule, if x is A, then y is B. Now, the same Jardine-Maxmin rule can be extended to another type of rule. Here I have mentioned the else part, right. If x is A, then y is B, else y is C. So, if it is like, then it can be expressed using Jardine-Maxmin rule composition. It is like this one. Okay. You can note that this part, that is instead of y we use C. Okay. So, this is the way that can be calculated, and the rest of the things is very similar to the previous calculation. Here basically this one. So, this else part is extra, else part is extra. If else C is added, then we can add this one in this Maxmin composition. Now, this is the example that is basically to calculate this one. So, let us see here, x and y are the two universes of discourse defined over the A fuzzy set, B fuzzy set is defined over x and y respectively. C is another fuzzy set defined over this universe of discourse. Now, this is the rule. We can calculate the rule using the Jardine-Maxmin composition. Here the A cross B calculation, and here A cross C calculation, and finally the rule R, this basically giving if x is A, then y is B, else z is C. So, this is the rule that we can consider for this rule computation. Now, so with this, let us conclude here about this fuzzy rule calculation. We have learned many methods, out of which we want to limit our what is called the process in order to Jardine-Maxmin method, and thank you.